Okay, welcome back to another video where we'll continue with working with Python and connecting to duckdb. So basically now I want to have a Jupyter notebook file. I will call SQL queries.ipnb so that we can be able to do many queries quite quick. So I'll do connect to database. I'll call this script. Or this Jupyter notebook, change the kernel to .vnv. So from here, I will do like this. So from date, actually, I will do a convenience. Remember that when we query, we do use the database query. We get the list, right? But I actually want to have data frames. That's very much nicer to work with. And the good thing is that in duckdb they have very easily you can get the data frame from the query. So let's do it like this. Let's move on. Let's go into our database and create another. I will actually remove this if under main name here. Because I don't need to run this anymore. Instead, I will also remove this constant because we will import this database into the Jupyter notebook later on. So let's create another class, database data frame, and it inherits the database. So it is also a context manager. How cool. So that query, okay, note that it inherits, but I want to overload this query. So when we run this database data frame, we will get back a data frame. That is the idea. So let's do it like this. So query self, comma, query. So I put in a query. So it's the same here, right? But I will return self.connection.execute query. And instead of doing fetch all, which will give me a list, I will do .df, which will give me a data frame. How cool is that? And also, in order to run this more smoothly, instead of just doing then you don't need to use the with statement all the time. I will create another convenience function or convenience class. So I will call this querydb, query database.py. And this will be the interface which we will use. So query database. So from database import database data frame, and from constants import database path. So this means that this will go into the database path and it will give me the connection to the database, and I will do it in a context manager so that you just need to call this class. So class query database and init. I will do SQL query here, and I will do with database data frame. This is the class I'm importing, and I'm putting in database path here as db. So I'm doing a context manager here, self.df equals to db.query SQL query. So basically I use this database data frame and I will expose this self.df. So basically you just do query database and .df in order to get the data. So yeah, this may sound a little bit abstract. So let's go into SQL queries and see how it works. So in this Jupyter notebook, I only need to do like this. From query database, import query database. So then I can do query database and I will do my query. Select star from supplier invoice, what it was called, dot invoice 2024, like this. And if I run this, IO exception, okay, could not set lock because this is already open, so I need to shut this down with Control D. So I run this one. Catalog exception, supplier invoice. Table invoice 2024 does not exist. 2024-08, right? Okay, it will run like this. So here we see we get back this database object, or this query database object. So I will just do .df. So you can see I got the data frame. How cool is that? So df equals to this. Df dot can do df dot head. So you see here's the data frame. And we can do df dot shape to see how much data there is. Okay, 92,000 rows. Great, great, great. So let me see here. We see belopp exclusive moms. This is how much it costs for different services. And I want to be able to do some calculations on this. So I will clean the data. So my idea is that I will clean this belopp exclusive moms. I will clean it with pandas. And then I will put it back into the database to show that it's possible to go from pandas to database, possible to go from, or pandas to SQL, it's possible to go from SQL to pandas as well. So both ways are working. So I will show you the other way now. So let's do like this. Clean cost column. So basically the cost is below, right? So a new code here. So let's do it like this. Df belopp exclusive moms. We get this one. To clean this with pandas is straightforward. So dot string. I want to remove comma 00 is basically the cents, right? So I want to remove that one. So colon -3 and it disappears. And also I want to continue dot string dot replace. I want to replace the space with nothing. So space with no space. And like this. And now I can do as type of int. Like I throw away the cents ören are so small amounts, so I don't really care about it here. So now it's int, right? So it's int 64. Perfect. So we can basically do df.lock. So I need to write it back to belopp exclusive moms equals to this one. Okay, this means that I'm slicing all the rows and taking out this column belopp exclusive moms and say it's equal to this one. So I have done some cleaning here and changed the type to int. So then I can do df.head. We can see that, yeah, we get this back here. Perfect. So now let's get it back to the database. So with database, now we need to import the database because remember that our query database only gives us the data frame. So that was a convenience function. So now we actually want to have back the other database. So from database import database, and with database, and then I also need to have the path, right? So from constants import database path. So I will put in database path as db, and then we'll do db.query. Or actually, we need to do like this first. db.connection.register. I will register the df and I will put in the variable df. Okay, so I put in the data frame and I register it and give it a name df so that I can use it to query from. So this is quite cool. This is really cool. You'll see how it works. So df.query, create schema, if not exists. I'll call it refine layer because when you are going more towards data engineering later on, if that is your interest, then we have something called the staging layer, refine layer, and marts when you're doing dimensional modeling. We won't go into that in this course, but I'll just, or the refine layer is also called warehouse layers sometimes. So basically what it means is that you have some data from before and you clean it and you do the transformations and you clean it in the refined layer, basically. So it's just another schema where I have the clean data, basically, the transform data. So I create this schema and then I will copy this one and I will create not schema here, but the table I want. Table if not exists, refine layer dot invoice 2024-08, right? So I create this table if it doesn't exist. However, okay, I'll do it into, or let's see, I'll do it into multi-line f-string. And I will do it like this. As select star from df, just like this. Okay, I'll run this one. Oh, so many errors. Okay, actually the error was quite hard to find because I'm quite tired. It was it says df instead of db, and df also has a query, but you cannot put this into the query, of course. So it's db query. So I'll run this one, and now it works. So let's check that it works. Let's continue here, and we can use the query database. So query database. Select, let's do it like this, select star from refine layer dot invoice 2024-08 dot df. Like this. Ah, it works. See, we get this back. Super cool, super cool. I will say .head also. So I don't need to show everything like this. So let's do some group by. So I will copy this part here. This is really cool now. I will do multi-line string. Select star from, let's do like this. Select star from this, right? So here we select star from refine layer.invoice and we do group by. Let's do like this. Group by. I want to group by leverantör, so the supplier, leverantör. And when I group by the leverantör, I want to select, I don't want to select star, I want to select leverantör. And I want to select the sum of belopp exklusive moms as summa SEK. So it's the Swedish crown. So I want to sum it together. So basically I want to group by all the supplier and see which supplier are the most expensive. How much do the supplier cost in total for each for this month? Right? So that is cool. So run this one, and I get an exception, of course. Group. Let's see, group by, yeah, I have the semicolon here. It should be in the end. Cool. Now we have group by each supplier. We see there's a lot of suppliers. That is also very, very interesting. But I want to do order. I want to sort this as well. So order by. I want to order by this summa SEK. Let's see. Yeah. Semicolon. You're making my day hard. Okay, but it's doing ascending. Okay, minus. That is quite interesting. Bostadsrättsföreningen Karlagatan, so it's the Karla Tower, Karlatornet. Hermods is a convict. Okay, so they are basically paying back to Göteborgs stad, I guess. Yes, but we'll do descending order. And here we can do, for example, we can do limit 10. And you can see the most expensive ones. Okay, so most expensive suppliers. Okay, Räddningstjänsten, yes, very important. Göteborgs stad leasing, yeah, okay. Yeah, they probably have a lot of services. This is retirement. Yeah, I can guess it's expensive. Purak, something with cleaning water. Renova is for handling trash and recycling. Västtrafik for bus and trams. Yeah, and some other. Attendo is probably for healthcare, I think, for elderly service. But this is really cool. So now we have been able to connect the database with Python, and we did a lot of queries. And thank you for listening to this, watching this video, and see you in the next one. Bye.